Welcome to this organic chemistry video about Newman projections. These are actually pretty easy to do, you just need a little practice with them. Alright, so we're just going to get started. I'm going to give you a structure with wedges and dashes. Remember, wedges are coming out of the page and dashes are going into the page. So we're going to draw this structure in a Newman projection without changing configuration. The eye is showing you the perspective you're looking down the structure in. First, we need to decide if the front carbon's a Y shape or an upside down Y shape by looking at our front carbon on the structure. Since we have a group in plane going down, we're going to do just the Y shape in front. The back carbon will do the similar thing. We have a group going up, so we have the upside down Y carbon. In the Newman projection, the crossed area is the front carbon and the circle is the back carbon. Now we have to decide where our groups go. Left and right, we have to look at the perspective of the structure. So if you're in the front of the structure looking at the front carbon, what group is going to be on your right side and what group is going to be on your left side? If we look, the ethyl is going to be on our right side and the hydrogen's on the left. Now we can do the same thing for the back carbon, looking at the perspective. So that back right carbon's isopropyl, back left is methyl, and the back top is ethyl. Okay, so now we're going to take the structure and draw it in the most stable Newman projection. We do this by figuring out the largest groups on the front carbon and then on the back carbon. This is more about bulkiness than weight. So I've circled our largest groups, and now we have to make them 180 degrees apart from each other. You can rotate either one to get to this configuration. Awesome. Feel free to pause the video whenever you need to. Okay, so let's do it again with a different structure. First we'll draw in a Newman without changing conformation, and then we'll draw in the most stable projection. Remember wedges and dashes, what they mean. And also, our perspective is very important. Because now we know where our front carbon is and where our back carbon is, we can add in hydrogens so we can see things a little better. Because we have a group in the front going down, we start with a Y in the front. We have a group in the back going up, so we'll start with an upside down Y. Now we have to figure out our left and right groups in the front carbon, and then in the back carbon. Awesome. Now we have to decide what our largest groups are. Front carbon will be our bulky ethyl, back carbon will be our bulky benzyl group. Now we gotta make them 180 degrees apart from each other. Just gotta rotate everything in the same way. Okay, here's the last one. It's the same drill, so we'll draw without changing conformation, and then we'll draw in the most stable. And then we're going to draw most stable as a wedge dash structure. Okay, we have our perspective. And we added hydrogens where we needed to. This time, we're going to have an upside down Y in this front and also in the back, so they're eclipsed. Our top is the isopropyl, and then our left and rights are as follows. Same with the back carbon. So we have to find our largest groups and make them 180 degrees apart for our most stable Newman projection. Now it's staggered. Okay, now we have to draw our most stable Newman projection as a wedge dash structure. Awesome. Good luck as you keep on studying. You got this. Subscribe for more videos. Let me know what other topics you'd like to see in the comments. It doesn't have to be organic chemistry.